This video will support you for question number 7, but I just want to clarify, if you are having a hard time, I recommend you going to Google Classroom and going to the classwork, and under classwork, if you scroll down, you'll find the topic called unit probability. Look for the word compound probability, click on it, and there's a video for you to watch to get more help on this. Anyways, I'm going to do a problem very, very similar to the one you were assigned. So let's go ahead and go into that. So let's go ahead and I'll actually read it to you. Assume Jennifer buys a pizza and randomly picks from the crust and cheese and topping menu. The probability of Jennifer picking a regular crust and mozzarella and pepperoni pizza is equal to 1/6. How does the probability of Jennifer randomly choosing a regular crust and mozzarella and pepperoni change if the restaurant adds stuffed crust to the crust category? Okay, that was a lot of reading. It's really important for you to try to understand what's going on. So I'll kind of break it up with annotating skills, and then hopefully we could build up upon this and find out what we're being told to find. Okay, assume Jennifer buys a pizza and randomly picks from the crust and cheese and topping menu. So right now we know Jennifer is going to pick a random item from these three categories. As we can observe, there's different options. This one only has one, but we'll get to that anyways. All right, the probability of Jennifer picking regular crust and mozzarella and pepperoni pizza is equal to 1/6. So the probability of her picking uh, particularly these items from these categories is 1/6. I'm going to quickly just go over it really quick and kind of explain where the 1/6 comes from. So the probability of her getting regular and mozzarella and pepperoni is equal to 1/6. This comes from the probability of regular times, because the and means times, the probability of mozzarella and times the probability of pepperoni. So looking at the category for crust, what is the probability of selecting regular? It's 1, but we could change 1 into a fraction. So it's going to be 1/1. We bring down the multiplication sign. We look at the mozzarella, the probability of picking it at random. It is 1/2, 2 or 1/2. And we bring down the multiplication sign. The probability of picking pepperoni randomly is 1/3. If you multiply these fractions out, you do get 1/6. That's where the 1/6 comes from in the problem. Okay, so how does the probability of Jennifer randomly choosing regular crust and mozzarella and pepperoni change if the restaurant adds stuffed crust to the crust category? So what happens if we add something to the menu? What if we add stuffed into the crust menu? What happens to the overall probability, this compound probability? So what the question is asking you to find now, and I hope you're able to identify it by now, is find the probability of regular crust and mozzarella and pepperoni. Okay, so that's the probability we're finding, and I'll go ahead and write it out as an equation right now. We're finding the probability of regular, R, and we're looking for the probability for mozzarella. That's in blue. I'm just color coding for you. And the probability of pepperoni for the toppings. Let me use green for that one. We're finding that compound probability of this problem. Okay, so we're going to break up this setup to individual probabilities. One probability will be the probability of picking a regular, R for regular, and go back to the purple to put the parentheses, the probability of that, and that means multiply by the probability of mozzarella, picking mozzarella randomly. So let me put M in there. And we're also interested, so we're going to multiply, remember, and means multiply, the probability of selecting pepperoni. Right, pepperoni. I apologize if it looks like an R. It's not my intention. That's a P. And I'll kind of clean it up a little bit right now. Okay, so just looking at the crust for the regular, what is the probability of us selecting the regular crust at random? Okay, I hope you were able to respond to me. That's 1/2. But we cannot forget that this is going to be multiplied by another probability of mozzarella. So looking at the cheeses, what's the probability of choosing mozzarella at random? I hope you're able to respond. That's 1/2. And we're going to multiply that by another probability. So what's the probability of selecting pepperoni at random? I hope you're able to identify that it's 1/3. Now, I hope that you get the idea. And basically, we just multiply these three fractions together. 1 times 1 times 1 is just 1. 2 times 2 is 4. 4 times 3 is 12. So your probability, based off this change in the crust menu, is 1/12. Now, compared to the original one, which was 1/6, you could actually get the decimal version. I think it's 1 point. Let me double check up on that with you before I give it to you. It's equal to 1/6. Now, if you convert this to a decimal, you should get, let's see, 0. You get 0.08. So this is about 8% probability of winning those combinations at random. This one is about 16%. So you have less chances of getting it once your menu expands, it gets bigger. So basically, this just tells you, hey, your probability of winning those choices gets smaller when your menu gets bigger. I hope that kind of clarifies what you're doing, but I do understand that your problem's a little bit more tougher. So I want to kind of modify this and do a different type of problem where it's a little bit more tougher. Okay, this problem is very, very similar to the one you're doing. So I'm going to go ahead and read it out loud to you. Assume that John will randomly select a different sport in fall and winter and spring. The probability of John playing football and soccer and swimming is equal to 1/8. Or actually, let me correct that. It's not actually 1/8 right now. Just give me a second. Is equal to 1/12. So the probability of John playing football and soccer and swimming is equal to 1/12. Very similar to your problem. Anyways, how does the probability of John randomly playing football and soccer and swimming change if golf is added to fall, tennis and wrestling is added to winter sports categories? Okay. So I'm not going to really deal with the 1/12. Just remember that it comes from the table originally. But there's something that we need to find from this problem. So I want to read it again to you again. Assume that John will randomly select a different sport in fall and in winter and spring. The probability of John playing football and soccer and summer is equal to 1/12 if he randomly selects a sport in each category. So, how does the probability of John randomly playing football and soccer and swimming change if golf is added to fall, tennis and wrestling is added to winter? Okay. So, what are we finding? Go ahead and think about it and respond to me. Okay, I hope you're able to identify that we're finding the probability of John playing football and soccer and swimming based on the change. Let me actually use a different color. Based on the change of golf being added to fall, tennis and wrestling being added in winter. So let me go ahead and enter those values in. I mean, yeah, those sports. So in fall, we're adding golf. In winter, we're adding tennis and wrestling. So right now, off the bat, you should know that your probability is going to get smaller. So, anyways, let's go back to what we're finding: the probability of football. And let me use blue, or randomly selecting football, and the probability of landing on or actually picking soccer. And for soccer, I'm going to use a weird yellow so you could see it. S for soccer. And we're also finding the probability of picking swimming. So and S. Oh, let me use orange. Swimming. SW for swimming. So what is the probability of choosing these three sports? So I'm gonna go ahead and split up this setup. So we're finding the probability of picking football randomly from fall. And we know that the word and means multiply. We're looking for the probability of picking soccer randomly. S for soccer. And means multiply again. Probability of swimming. We want to find those probabilities. SW for swimming. All right. So, first question is, what is the probability of selecting football in fall from these sports? Go ahead and respond. And I hope you're able to notice that with the changes, with the addition of golf, you have 1/3 probability of selecting football at random. Remember, drop down the multiplication symbol. The probability of selecting soccer at random in winter is now 1/4. Don't forget the multiplication sign. Now the probability of selecting swimming in spring is now 1/3, or it has been 1/3 actually, because nothing changed in that category. If you multiply these fractions out, you'll find out that the probability of him selecting football, soccer, and swimming has now decreased. And let me go ahead. You multiply tops with tops, which is just still 1, over 3 times 4, that's 12. 12 times 3 is 36. You will find out that the probability is 1 over 36 compared to how it used to be, 1 over 12. Uh, if you convert these two fractions into decimals, you'll find out that the bigger your categories become, the smaller probability you have of having those sports chosen at random. And I could actually definitely prove that to you right now. Based off this calculation, you have about 2%. And over here, you have about, let me go ahead and do that really quick, about 8% probability of selecting that sport. Anyways, this kind of summarizes what you're expected to do for that problem.